Cheyenne Mountain, a rugged Rocky Mountain peak rising boldly from America's vast central plains. Radar picks up an unidentified object in the skies over central Russia. It's traveling fast and heading toward the Pacific Ocean. Prompt response is vital to the defense of the nation. Highly trained teams scan intelligence reports to determine the correct action. Though it's a scenario that is played out hundreds of times, the men and women on duty here know that a moment like this could be the one that puts them to the ultimate test. This is the headquarters of the North American Aerospace Defense Command, NORAD. NORAD's eyes can not only see the entire surface of the Earth, they also gaze 22,500 miles up into the heavens, where they intently probe 27 trillion cubic miles of aerospace. Cheyenne Mountain's labyrinth conceals NORAD's military wonders. Its existence has always been well known. Getting all this technology inside a mountain was one of the 20th century's toughest engineering challenges. The builders wrenched 460,000 cubic yards of hard rock from the core of the mountain and replaced it with 7,000 tons of steel, yards of concrete, and miles of wiring. What drove men to hollow out a mountain and build this amazing superstructure? It was fear. In the 1940s and 50s, mankind unleashed the power of the stars on the face of the planet. Nuclear weapons darkened America's post-war optimism with fears of Armageddon. At the beginning of the nuclear age, the technology to build a working city deep within a mountain, strong enough to endure a nuclear blast, did not exist. In America, the Soviet threat gave birth to a massive campaign called civil defense.
You know how bad sunburn can feel. The atomic bomb flash could burn you worse than a terrible sunburn.
There was a trailer by the name of Bert.
While the public watched upbeat training films, federal and local authorities built shelters and tried to prepare for the worst. In 1957, Canada and the United States formed the North American Air Defense Command, or NORAD, to operate the continent's early warning front line against attack by the Soviet Union. To detect incoming bombers, Canada and the U.S. cooperated to build a series of radar outposts across the far north. The Dew, Mid-Canada, and Pine Tree lines provided early warning of enemy attack over the North Pole. But the new defense system suffered from a fatal flaw. NORAD headquarters was an old hospital building, a masonry structure built in the 1920s. A direct hit from an old-fashioned conventional bomb could have knocked it flat. A nuclear attack would have turned it to dust. In 1956, the Continental Air Defense Commander reported that a man with a bazooka passing in a car could put the establishment out of commission. To fight its Cold War with Russia, America had to build something previously unimagined. A hardened command center that could survive the devastating power of an atomic bomb. The daunting challenge for military engineers was how and where such a building could be constructed, or even if it could. With America in daily danger, they had to succeed. The first design followed the plan of the Strategic Air Command headquarters at Omaha, Nebraska. This plan combined an above-ground headquarters with an underground combat operations center. But defense planners protested that this design was too vulnerable for a facility as important as NORAD headquarters. In the fall of 1962, the Soviets suddenly brought the nuclear threat to America's front porch. Aerial photographs revealed that the Russians had placed missiles capable of carrying powerful nuclear warheads on the island of Cuba, a scant 90 miles from our nearest shore. Both sides went nose to nose and prepared for the worst. In the wake of the Cuban Missile Crisis, work proceeded on NORAD with an even greater sense of purpose. The project was put on what is called a wartime construction schedule. It was to be completed as soon as possible. Before work began, geologists and soils engineers drilled test holes to discover if the rock would support the enormous cavern that needed to be hollowed out of the belly of the mountain. But it was not enough just to smooth the cracks in the cavern. The engineers also needed to strengthen the hollowed-out sections of the mountain so that it could withstand the power of a nuclear blast. To do this would require taking a mining technology to a level where it had never been before. And the result was one of the greatest innovations of Cheyenne Mountain, rock bolting. Each bolt was torqued to 275 foot-pounds. A 1-inch diameter, 6-foot-long bolt created a tension of 10,000 pounds on the exposed rock face. This tension fooled the mountain into thinking it still had a center. Just as the engineers began to believe that they had conquered the interior challenges of Cheyenne Mountain, a shocking discovery threatened to derail the entire project for good. They found that the mountain had a fatal weakness.
When they picked the mountain, they thought it was going to be the best mountain in the world, but when they got inside of it, they found it was rotten in the core.
To make matters worse, this fractured rock zone was precisely over the tunnel intersection where NORAD's Operations Center was to be placed. This dome, although unplanned, is one of the greatest engineering marvels of Cheyenne Mountain. It took nearly 2 years to complete. The form for the dome was constructed outside Cheyenne Mountain. Once complete, it was then disassembled for the move underground. At 100 feet in diameter, the form was a mammoth jigsaw puzzle. Putting the pieces back together inside the mountain presented Kiesel and his team with another challenge. Despite the added work over the command center, NORAD's interior protective shell was finally completed in May of 1965. The steel buildings that would eventually provide 208,000 square feet of working space took their place within the 2.5 miles of tunnels in the cavern. Now it would take 8 months just to install the complex electrical and surveillance equipment inside the mountain. The centerpiece of the new command center was an $800,000 combination camera processor projector that could display a 12 by 16-foot image of the planet in 7 colors. After nearly 5 years of work, at a present-day replacement cost of $18 billion, the Cheyenne Mountain Complex became fully operational on April 20th, 1966. The men who designed, engineered, and built the massive underground center were proud of their work. They were also quite aware of its limitations. Everyone hoped that this superstructure would never be put to the test. Even more, they prayed that it would survive that test. In the end, NORAD's survival rested on a principle called circular error probability. CEP was simply the probability that a nuclear weapon fired from halfway around the world would fail to score a direct hit on Cheyenne Mountain. Even though it cannot survive a direct hit, the command center is designed and built to resist the effects of a nuclear weapon: blast, heat, seismic shock, electromagnetic pulse, and radiation. The access tunnels weaken the effects of blast and heat simply by letting the blast wave pass through the tunnel unimpeded. To avoid a direct strike by the blast wave, the designers located the blast valves and blast doors at right angles to the tunnels. At the first sign of a credible nuclear threat, the blast doors are closed and Cheyenne Mountain is sealed off from the outside world. Another engineering innovation at Cheyenne Mountain is designed to protect NORAD from the seismic shock of a nuclear blast. Massive steel springs, more than 1,300 of them, support each of the 15 buildings in the complex. NORAD's gigantic springs work so well that the concept of seismic shock isolation has been incorporated into many modern buildings in earthquake zones. Flexible passageways and couplings allow the buildings to sway independently without breaking vital connections. But the designers needed even more reinforcement to meet the challenge of a nuclear bomb's electromagnetic pulse, or EMP. This tremendous burst of energy, similar to but far more powerful than a lightning strike, can destroy sensitive electronic equipment and damage even sturdy electrical circuits. To combat its effects, the engineers constructed the buildings like the hull of a ship or fuselage of an airplane. The continuously welded 3/8-inch thick steel skin gave structural strength as well as electromagnetic pulse protection. Even the backup power has a backup. 3,400 powerful battery cells maintain what is called uninterruptible power supply, or UPS, for the operation of NORAD. It is one of the largest backup power systems ever built. Perhaps the most important supply for the operation of NORAD is water. More than 1.5 million gallons of drinking and 4.5 million gallons of industrial water are stored here. Cheyenne Mountain must also regulate its air supply. Air enters through two sources, the north and south portals, and then is directed through a so-called air delay path. This construction is crucial to prevent damage from the force of a nuclear blast and the pressure pulse it would create, a destructive blast of air traveling at the speed of sound. The air delay tunnels are equipped with blast valves, one of the ingenious design elements of Cheyenne Mountain's respiratory system. The mountain must also be able to repel chemical, biological, or radiological contaminants. To combat that threat, the engineers can force outside air through sophisticated CBR filters in the cooling towers. Cheyenne Mountain is more than just a panoply of technological wonders. It's a place where people live their lives and do their jobs. More than 1,200 people keep the complex functioning on a 24-hour-a-day, year-round basis. The NORAD Operations Center in Cheyenne Mountain has faithfully fulfilled its mission. But was that mission necessary, or was it Cold War paranoia? Now that the Cold War is over, we know that the Soviet threat to North America was real. The Soviet plan for global thermonuclear war was revealed in a 1985 report. It consisted of a surprise attack that would be launched on several fronts. Land, sea, and air-based elements of the Soviet military forces would simultaneously attack targets in Western Europe and in North America. The first barrage would destroy U.S. coastal cities and create an electromagnetic pulse that would disrupt satellite and ground communications. The Soviets estimated that in the first 20 minutes of this massive nuclear assault, 75 to 125 million Americans would be killed. Cheyenne Mountain was high on the list of primary targets. The Soviet attack never came. The Cold War is over. Some say NORAD has outlived its usefulness. Others say a threat is still present. It has only changed hands. For nearly 40 years, the world trembled under the cloud of imminent nuclear annihilation. For all this military buildup, Cheyenne Mountain has entered an advanced state of alert only once in its history. It was in October 1973, during the Yom Kippur War, as the Arab allies advanced on Israel. America ordered B-52s armed with nuclear bombs into the air. American missile launchers went into a pre-launch check as NORAD monitored the war. The American military was placed on defense condition, or DEFCON 3, an advanced state of alert halfway between peace and thermonuclear warfare. The alert warned the Soviet Union's Arab allies that an invasion of Israel would not be tolerated. The advance was halted and the alert relaxed. Then, in the late 1980s, the Soviet Empire collapsed, and with it, so did much of its nuclear threat. Today, the Cold War is over. NORAD has been forced to redefine its role, yet its mission remains the same. Make certain that nothing enters U.S. airspace that we don't know about. And today, there are many more potential threats. Some of them are external, from new nuclear states, like India, Pakistan, North Korea, or from former Soviet republics. Iran and Iraq could soon join the nuclear club. And China already has nuclear-capable ballistic missiles. Conventional weapons remain a threat. During the Gulf War, NORAD closely monitored Iraqi missile strikes, coordinating with Allied theater commanders in Saudi Arabia and Israel. It was able to issue warnings of Scud missile launches that were relayed to troops on the ground.